Hello friends, so today in this video we're going to discuss the first 4 problems from the latest AtCoder Beginner Contest 203. So I will tell you the 4 problems. The first 3 problems are not too difficult, but the fourth problem is very good and it's also difficult, so stay tuned till the end. The first problem is Takahashi drew 3 dice, so actually he threw 3 dice and they show the numbers ABC. So if there are 2 numbers same in ABC, print the remaining number. So in the numbers which are appearing in the dice, if 2 numbers are same, then you'll print the third number, otherwise just print out 0. So there can be a lot of ways to solve this problem out. I just thought about like solving out this problem is, if any 2 numbers are same, okay, then you have to find out the third number. And if 2 numbers are same, obviously if you do a XOR of all the 3 numbers, the 2 numbers will cancel out each other, and the next, like the last number which is remaining, is a new number. And else if all the 3 numbers are different, then just print out 0. I hope you understand, like you get the point. So I can show you my code part also. So all the code will be in the description, you can check those code out also. So the first code is like this. As you can see, you just take the input of all the 3 numbers. If any of the numbers are same, if A equal to B or B equal to C, any 2 numbers are same, then the answer is just do a XOR of the 3 numbers, because the XOR of these numbers will be eventually result in the cancelling of the 2 numbers which are same, and the last number is just printed out. Else if any 2 numbers, like if all the 3 numbers are different, then the answer is 0. Okay. The second problem is, so you are given some sort of a building in which every in building there are different floors, and in each floor there are some rooms. So there are n floors and k rooms in each floor, and the numbering given to them is like 10j, like I0j. So in the first floor, the first room is 101, then 102, 103, as you can tell, k rooms. Then the second floor is 201, 202, 203, and so on. So now as you can see, n and k are very small, so you just have to find out till, so Takahashi got interested in the sum of the rooms of all the rooms in this conundrum. So sum of the numbers, or sum of these numbers of all the rooms in this building. So what you can easily do here is just iterate over every floor, get that floor room numbers and just add them out. So it's not too difficult, you can just easily write that down also. The code will be in description, you can check the code out also. I can show you the code part also, but it's not too difficult. So as you can see in this code also, I just iterate over every possible room, every possible floor from 1 till n, and for every floor iterate over every room, then find out that room number and just add in total and just print out the total. Okay. The third problem is, actually there are a lot, as you can see, 10 to the power 100 villages in a line. Now what you can do here is, in every village, if you want to go from the 0th, you starting at the 0th village, if you want to go to the next village, you have to like pay 1 yen, 1 rupees, or you can say anything. You have to pay 1 yen to go from village I to village I plus 1. Okay. Now you also have some friends, n friends, and each friend is at the village AI, which will give you bi yen also. So you start with some k yens at the 0th village. So you are starting at the 0th point and k yens you have. Now if you move through some village, and if you got to some village, and if there is a friend in that village, the friend will give you BIN, and then you can also use that to move further. So what is the farthest village you can get? So the simplest explanation for this problem can be, first sort out all the villages according to their like indexes out. Okay, then what you can do, so you're starting at the 0th index, 0th village, then you can go, like your next motive is to reach the next village, which is the closest village at which you can get a friend. Because if you can reach that village, you can reach that village, the number of yens spent, how much energy you have spent to reach that village, is the distance between that village and your starting point, or the village at which you are, the subtract between that, and then how much yen you can get when you reach that village. You can get BIN, and you can keep on doing that until now you cannot move. Now if you cannot go to the next village, or all the villages are exhausted, you are at the last point, now still you can have some yen left. So what I mean by this is, let's assume that the next village in which your friend is 100 villages away from you. Okay, and now it means that you cannot reach, maybe you have only 50 yen left. If you have only 50 yen left, 50 rupees left, you cannot reach the next village. So, and if you are, let's assume, at some 25th village, and the next person is at 100th village, the friend you, and you have 50 more coins, so you can only reach the 75th village, you cannot reach there. So the answer is, the final village you can reach plus the amount of coins you have, because every coin can increment your village by 1. I hope you get the point. So you can also just reduce that logic. It's not too difficult also. So the third problem is also not difficult. I can show you the code part now. So you just do everything in long because the constraints are long enough. So what you can do here is, in this problem is, just take the input of all the villages and the amount of money you will get if you reach that village. Then you can sort all the villages according to their positions. Then you start with 0 at the village you are, like the starting village, and you have k coins. Now what you'll do, you'll iterate over every village, because you have every village means not every village from 0 to 1, every village in which your friend is, because your main target is to reach the village in which your friend lives. So what is the amount of distance you have to travel to reach that? The distance is the previous distance at which you are, which is this village distance, and the distance at which the nearest friend is. The nearest friend is at ai dot first, because first is the village, the second is the amount of money you will get to reach that village after you reach that village. Okay, so if this distance is less than equal to k, because you can only reach that village if you have some money with you. If you don't have that much amount of money, so as I've told you, if the next closest village is 50 kilometers away, and for every kilometer you have to spend 1 yen. Now if you have only 40 yen, how you can reach that? So you have to also ensure that the distance, if the amount of money you have is greater than equal to distance, then only you can do that. Now if you have that amount of money, what you'll do, you will travel to that village. So how much money you have exhausted, the amount of distance you have traveled, so you will subtract that. Now if you have reached that place, how much money you will get? The money you will get is, you have to add ai dot second, because that's the amount of money you will receive from that friend in that village. And what is the new village at you are at ai dot first, and you will keep on doing this until you cannot reach the next village. So at that point you will break. So the final, and if you break at that point, you still have some money left, so you can add k into the village, and the answer is just village at which you can finally reach. So you can look into the code, all of them code will be in the description. You can check those code out also. The fourth problem is pretty good. It actually states that you are given a park which is having a dimension of n cross n grid. So you have an n cross n grid, and every grid position has some sort of a building. You can assume, or some sort of a column which has the height aij. Okay, now you are the manager. Takahashi the manager had decided to build a pond occupying k cross k squares in this park. So you have to, so I can draw it out also. So sorry, okay, so there is some park n cross n. Okay, so it is divided into particular grids. This is not n cross n, I'm just trying to tell you how this grid is looking like. And then you have to draw some k, let's assume k equal to 2. So you have to draw a 2 by 2 square in this whole grid, like any 2 by 2 square you can choose. Okay, now you have to choose such a square such that that square should be completely inside the park, which is obviously true, and whose median of the heights of the square is the lowest. Now you have to choose a square such that if you find out the median of all the heights in this square, it should be the minimum. Okay, now you have to find out the median of the height of the square in such a like a pond. So you have to find out the smallest median of a k by k square. Okay, now median is if you have like common like the explanation about median is just if you sort all the values in this square, the middle point, okay, is actually the median. So you can also denote it by this, which is like finding out, so total number of squares grid into this, like total number of grid points into the pond is equal to k square, because the length is k. So total number of k square, so k square divided by 2, do a floor of it plus 1. That's the number of the median of that pond. So in simple terms, you are actually having to find out the smallest median of a pond you have to make in this whole park of k cross k. So you have the park dimension is n cross n, and you have to make a pond of k cross k. Now at first I also do not understand how to solve it out, so I just look into pretty much a lot of solutions to understand it. And the basic intuition to solve this problem out is using binary search. Now how you can solve this using binary search is, So the simple thing what you can understand is, if you take any square, if you take out any square, then if you find out a median, so let's assume that I find out, or if I'm checking that whether there is a square which is having a median 5. If I find out that a square is having a median 5, then obviously like there can be a possibility that there is a smaller median also. Okay, there can be a larger median, but I'm looking for a smaller median. So if I just take a lower bound and an upper bound, like a lower pointer, upper pointer, I find out for the middle value. So let's assume that I take two values. Let's assume my left is equal to 0 and my right is equal to 10. I find it for the middle equal to 5. So for 5, I just want to find out that whether I can form a grid, a pond in this whole grid such that its median is equal to 5. Can I easily make that out or not? If I can build that out or not? That's my main target till now. So how I can do that? That's my new target, and that's what we're going to discuss here. How can we find out in O of n square? Because then it will become like O of log of n into n square. Okay, that can be easily achieved. So because it cannot be done in an O of n cube, even though the as you can see, the constraints are up to 800 only, but if you do a 10 to the power n cube of this 800, then it will over exceed obviously. Okay, so in n of cube you can easily do that, iterate over every possible square grid, okay, and then just find out that what is the minimum among all of them, and that can be the answer. But the problem is that 800 square cannot be done. So what we'll do in this problem is we'll do a log of it. So we can find out that whether a square grid of like maybe the median of 5 exists in this whole or not. Now how we can do that? So the main problem, like after seeing a lot of solutions, what I came up with is, I'll tell you how they solve this problem out. So first we have some numbers in this grid, so which denotes different heights. Okay, if we have different heights and we want a median of at least 5, okay, then like median of 5, so what I can do here is first find out all the numbers which are less than 5, okay, which means that if I have those numbers, then obviously I have a median of that 5 only, because if all the numbers are less than equal to 5, then obviously if I find out a median of all of the numbers, it would be at least 5 only, like it can be less than equal to 5. It cannot exceed 5, because I am looking for a median less than equal to 5, because I'm just checking that whether there is a median existing less than equal to 5. So I'm just checking for 5. So what I'll do, I'll make this grid, and for every number I'm iterate from left to right over every number, and just make a 0 1 like a binary grid of checking that whether comparing every height with 5. If it is less than equal to 5, then we'll make it 1, and if it is greater than equal to 5, then if it is greater than 5, then we'll make it 0. So we'll only care about those positions which are having ones. Okay, then it will actually tell me that, okay, maybe if I'm looking for this grid, if I have some ones, then that will actually tell me how many 5s are, like how many numbers are there which are less than equal to 5. If I even sort these numbers out, so see, in median what I'll do, I will take out all the buildings in this grid and then sort the grids out, okay, and then find out the middle position. Okay, so as you can see, if I just find out that maybe let's assume I have 4 positions, and the number of ones I have is greater than, so if I sort them out, then it will be like this 0 1 1 1. But as you can see, 1 is actually in the front, because 1 is like smaller. So smaller number means that the smaller number will be in the front, and then the larger 0 means that they are the end. So just assume that 0 means that these numbers are greater than 5. So greater than 5. So if we just sort them out, if we take this grid in the original position and we sort them out, then the sorting will be like this 1 1 1 and 0. So it means that if this number is at the middle, if the number of ones are greater than equal to this k square divided by 2 plus 1, then it actually means that I have a 1 here. 1 here means that I have at least a position which is having a median of at least 5 there. If it is having a position of 5, then I have already find out a grid which is having like 1 there, like which is satisfying my condition. So my goal is to find out a grid or like a pond in which the number of ones is greater than equal to k square by 2 plus 1. Now still I cannot count out number of ones manually, so I have to use dynamic programming here. Now if you know that if you want to count out a number of ones in this, okay, then maybe you can use a prefix, some sort of things, but the thing is that can also give time limit exceed. You have to just find out the number of ones in every rectangle of size k in O of 1. How you can find out? So this is like a standard DP problem only. So if you want to find out some, like maybe, so I can draw it out, this like finding out the number of, like the sum of the values in some rectangle which is given to you. So this is also like a DP problem, which is somewhat like this, that you are given some grid and every grid position has some value, and you just have to tell what is the number of or the sum of the values in this position, in O of n, or in this position. So there are n queries and you are given the top left and the right bottom point, and you have to tell the number of summations of all the values in this position. So it's a standard DP problem. How you can solve this problem out? If you want to find out, so what you'll do, you will find out, or actually make a DP table such that every grid position at this position is storing out the sum of all the values starting from this position till this position. So every grid point like this is storing out the sum of these values. So if you, like for this position it is storing out this value, for this position is storing out this value, for this position is storing out this value. So how you can do that? The DP of this value is addition of this and minus of this. Okay, so if you do some addition of this and subtract this value, then you will get a DP such that it store out the values till this point. Now if you have this point, like rectangles forming at like this, if you want to find out a value of rectangle like this, how you can find out? The value of rectangle, the summation of all the values in this rectangle is equal to the DP value of this, because that will store out the DP value of this rectangle. Okay, then you have to subtract out this part and this part. So this is just DP of this, subtract out this, DP of this, but now you have subtracted out this part twice, so you have to add DP of this value. So the DP of this rectangle is, like the sum of the values of this rectangle is DP value of this value, subtraction of the DP value of this triangle, and addition of this triangle. And you have to do this for all the rectangles of size k, and then you can just find out that any rectangle such that now you have only ones and zeros, and that will tell you whether how many ones are there in each rectangle of size k, or like a square of size k. You have to iterate over all of the squares. In O of n, you can just do a DP of O of n square, and then iterate over every position and find out the values in O of 1. And then for every square position, you just tell that or check that whether it is possible to make a square such that its median is less than equal to the middle value. If it is fine, then what we'll do, we'll make a right pointer go to the mid, else we'll move our left pointer +1, and then we'll just find out the answer, which is like the final answer. So I hope you get the point how to solve this problem out, the intuition part. You can understand the code part also. The code will be in the description, so you want to check that out, you can check that out also. I've also looked a lot of code to find out this solution, but yeah. So what you can see in this problem is, first we will make n and n, take the input of all of them, then this is left and right. We will do a binary search like this, and then find out the middle value. If we just make a check whether this middle value over this whole grid is valid or not. If it is valid, then move my right equal to mid, else left equal to mid +1, and the answer is right. Okay, then what we'll checking in this function, for this middle value, we'll iterate over this whole grid value and find out that whether the particular building height is less than equal to the mid value, which I've told you. Then we'll make that part equal to 1 or 0. Then we'll make a DP position which is storing out the values of the rectangles. Okay, then what we have to do here is just iterate from left to right. For every ij, the value is equal to the current value plus the top value, side value, minus the diagonal value, and that's the DP value, which will store every rectangle starting from 0, 0 to I, j. So that will store out for every I, j, what is the total sum number of ones starting from 0, 0, 0 till I, j. And if you want to find out the number of ones in every square of size 1, then we'll iterate over every position, and then we'll check that for every position what is the number of ones there. So the size grid is equal to dp of, if we are starting from 0, 0, the first end point is k, k minus I j, plus, like j plus k, I plus k, j. So it actually just subtracting out these rectangles, and also we have to also add out one rectangle which we have like subtracted out 2 times. So as you can see, if we're starting from this point, the rectangle is this, add, subtract out this rectangle, and add this rectangle one more because we have double subtracted out. And that's the solution. And just if the total number of ones in this is greater than equal to k square plus 1 divided by 2, okay, then we just print out true. Else if we haven't found out anything, then the answer is false for this check function. And if we just return out check like true for anything, then we just print out or else false. We hope you understand the logic and the code for this problem. If you have any doubts, you can mention it on the comment box. As soon as until then, keep coding and bye.